Hi students, today we are going to study one of the very important theorem in physics, namely Bernoulli's theorem. So this is from the chapter Properties of Matter. Now what is the statement of Bernoulli's theorem? First of all, you should be very thorough. For the streamlined flow of a non-viscous and incompressible fluid, the sum of its pressure energy, kinetic energy and potential energy per unit mass remains constant. So when a liquid is in flow, how many types of energy it will possess is 3 types. What are they? They are the pressure energy due to its pressure, kinetic energy due to its motion, and potential energy due to its height or position from a fixed surface. Now first we are supposed to draw a neat diagram with all information correctly. Now this type of pipe is having a non-uniform cross section. So at the end A it is wider, at the end B it is very narrow. So what is the area of cross section of the left end A is small a1. And the area of cross section of this pipe is A2 at the end B. Now the pressure at the left end is P1. So P1 is equal to what? H1 into rho into G, where H1 is the height from the ground surface. And what is the pressure of the liquid which is leaving out at the end B? That is equal to H2 into rho into G. So P1 is the pressure at the left end and P2 is the pressure at the right end. Similarly, the velocity with which the liquid enters into the pipe at A is V1 and the velocity of the liquid which is leaving the pipe at B is V2. So all these 4 factors, pressure P1, velocity V1, area of cross section A1 and the height H1 on the left side should be marked first. At the right end B, so P2 is the pressure, B2 is the velocity, A2 is the area of cross section and H2 is the height from the ground level. Now what is to be proved here? The sum total of its pressure energy, kinetic energy and potential energy per unit mass. So the total pressure energy is what? MP by rho. So per unit mass it becomes what? P by rho. What is the expression for total kinetic energy is mv square by 2. So per unit mass it should be V square by 2. Similarly, potential energy expression is mgh. So per unit mass means it is gh. So we have to prove that P by rho plus V square by 2 plus gh is equal to a constant. Now just like the steady flow of the liquid, steadily you write the steps. Before getting into the derivation, I want to recall you the very important information, namely the equation of continuity. So the equation of continuity is what? A1 into V1 is equal to what? A2 into V2. And the very important fact on which this continuity equation is derived is what? The mass of the liquid entering at A at any time is equal to the mass of the liquid leaving at B in the same time. Okay. Also, the volume of the liquid entering at A in a given time must also be equal to what? The volume of the liquid which is leaving at the other end B. Understand? So please keep it in mind. The volume of the liquid as well as the mass of the liquid entering at A must be equal to the volume of the liquid and mass of the liquid leaving at B. So with reference to which we are going to now prove the theorem. So first, my dear students, I will take the left side end A. So at the point A I will take. Okay. So what is the pressure of the liquid at A is P1 and the area of cross section is A1. Therefore, what is the force exerted by the liquid at the end A? Okay. Force exerted by the liquid at the end A. So this is equal to pressure into area, P1 into A1. Okay. Now with what velocity the liquid is entering at A is V1. So in a given time t, how much distance it must have traveled? The distance traveled by the liquid, okay, d is equal to the velocity v1 into the time t. So this must be the distance traveled. Okay, by the same time, how much volume of the liquid must have flown through the end A? The volume of the liquid V is equal to area A1 into distance. So this is equal to what? Area A1 into V1 into T. So this must be the volume of the liquid which is entering at A. Why I am not writing V1 here, the volume at end A? Because volume of the liquid entering at A must be equal to the volume of the liquid leaving at B. Therefore, I need not write V1 and V2. Both are equal, so I am not using the subscript. So capital D represents the volume of the liquid entering at A. That is equal to A1 into D, that is A1 into V1 into T. Okay, now what is the work done by the liquid at the point A? Now I will write work done, okay, by the liquid. Work done by the liquid or fluid at A. So that is taken as WA I will take. Okay. So that is force FA into distance. Force into distance is equal to work done, is it not? So instead of the force FA, I will substitute P1 into A1. So this is P1 into A1 into the distance. Distance is what? V1 into T. So V1 into T. Okay. Now A1 into V1 into T is also equal to V, the volume of the liquid entering inside the tube at A. Is it not? Therefore, instead of A1 V1 T, I can substitute what? P1 V. So this is what? P1 into V. So WA, the work done by the liquid at A is equal to what? P1 into V. This work done by the liquid only is equal to the pressure energy. Understand? This only is equal to what? The pressure energy. Therefore, pressure energy, the pressure energy at A, okay, at A is given by EPA. So care must be taken, my dear students. PE means potential energy we had been used to. Now EP means what? It is the pressure energy. Suffix A means what? It is the pressure energy of the liquid at A. So this work done WA only is equal to what? Becomes pressure energy. So this is also equal to what? P1 into V. So this is the first step. Okay, this is the first step. Next, the kinetic energy. Okay, kinetic energy of the entire mass of the liquid at A. So this is given by KE at A is equal to half m into V1 square. So this is equation 2. So V1 is the velocity of the liquid, m is the mass of the liquid flowing in that time. So half m into V1 square. Now next is what? The potential energy. Okay. So the potential energy at A for the entire mass of the liquid is PEA, that is equal to mg into H1. This is equation 3. Okay. So I have written the expressions for the total pressure energy, total kinetic energy and the total potential energy for the entire mass of the liquid. So if I add all these three, what do I get is the total energy of the liquid. Okay. Therefore, total energy, okay, total energy of a liquid at A. So this is taken as a E suffix A. Okay, so I have to add all these three terms on the right hand side. P1 V. So this is P1 into V plus m V1 square by 2. So this is m V1 square by 2 and plus m into G into H1. Okay. Now what is the expression for density? Density of the liquid rho equal to mass by volume. Is it not? Density is equal to what? Mass by volume. Therefore what must be volume is equal to mass by density. So I can substitute this volume of the liquid by what? Mass by density. So this also is equal to what? M by rho. Volume is what? Mass by density into P1 plus M V1 square by 2 plus mgh1. So the left hand side is total energy. Therefore, now total energy, okay, I can find out the total energy per unit mass here itself. But let it be as it is now. This is the total energy of the liquid for the entire mass I have written. This is at which point? At the point A. Similarly, I will write, okay, similarly, I will write at the point B. So at the point B, if I will write the similar equations individually, I need not write. In the final equation itself, I can substitute. So this equation can be taken as 4. Now, similar equation for the point B. What is the total energy? The sum total of pressure energy, kinetic energy and potential energy at point B. So this must be equal to what? M into P2 by rho. So instead of pressure P1, I have to substitute P2. Density of the liquid remains the same and the mass of the liquid entering is equal to the mass of the liquid leaving at B. Therefore, M also should be same. So this second term becomes what? M into V2 square by 2 plus mg into H2, and this is equation 5. Have you understood this? So if at all you want to write all these steps, you write for B also, but that is not necessary. So similarly at the point B, EB is equal to sum of the 3 terms for the total mass of the liquid. Okay, now this theorem is based on what principle? Is the law of conservation of energy. So from conservation of energy. So that is the principle of working of this theorem. Okay, from the conservation of energy, this energy EA must be equal to the energy EB. So I will substitute M P1 by rho plus V1 square mv1 square by 2 plus mgh1. This must be equal to m into P2 by rho plus m into V2 square by 2 plus mgh2. Now we can cancel the term m on both sides. Okay, after cancelling this factor m on both sides, now P1 by rho plus V1 square by 2 plus gh1 must be equal to what? P2 by rho plus V2 square by 2 plus gh2. Or we can write R P by rho plus V square by 2 plus gh is equal to a constant. So this is our proof now. So this is also the last equation number 6. Now what is to be proved? We have written already. You see that we have to prove P by rho plus V square by 2 plus gh is equal to constant. Have you got the same equation here also? P by rho is what? Pressure energy per unit mass. V square by 2 means what? Kinetic energy per unit mass. And gh means what? Potential energy per unit mass. So we have proved the Bernoulli's theorem based on the principle of what? The law of conservation of energy. Understand? Now as a special note, if for a horizontal pipe, suppose if the axis, that is if H1 is equal to H2, okay, so that both the ends A and B have the same axis, same horizontal, okay. So for horizontal pipe, we can take H1 is equal to H2 is equal to H is equal to what? Constant. So for that we can extend the theorem as what? P by rho plus V square by 2 is equal to a constant. So this is the equation number 7. So many applications of Bernoulli's theorem are based on this equation by considering the level of both the ends A and B to be equal from a reference level. So this is the final extension. Now my dear students, this pipe of non-uniform cross section in some other textbooks and competitive exam books, they have given another name for this, that is also called as datum. D-A-T-U-M, datum. Okay my dear students, now I will recall what is Bernoulli's theorem statement. We have to be very careful with the words. First, how to begin this? For the streamline flow of what liquid? Yes, non-viscous and incompressible. So you have to underline the terms streamline. Okay. So streamline flow, then non-viscous and incompressible fluid. Then you have to keep in mind that the sum total of its pressure energy, kinetic energy and potential energy per unit mass. This has to be underlined in the examination. So these four terms must be underlined so that the paper evaluator will be very happy with your performance. Okay. So next we have to draw the diagram. It is better if you write the principle as a separate point. So here itself you can write separately. Next point is what? The principle. So the principle is law of conservation of energy. Okay. Separately we can write. Anyhow, we are going to write in between also. So after the statement, you write the principle. Then you draw the diagram and what is to be proved. Separately, you write this equation. Then you start with the left end A. So you get the expression for the force, distance and volume of the liquid. Then work done. Then automatically you will continue with the correct sequence. Then at the point B, once again you need not derive. Okay. So this is the shortest and easiest way of deriving Bernoulli's theorem. I hope you must have understood well. Fine.